All right, so here we've got quadratic equations that have xy terms, which are referred to as a cross product. So essentially what we're going to be doing is rotating our axes. So these are our axis rotations. So because if you have an xy term, it means the graph's going to be tilted. It's not going to lie perfectly on the x-axis or perfectly vertical on the y, perfectly horizontal on the x. It's going to be sitting at some angle. So if you think about an ellipse, the ellipse would be like doing this. So the major axis does not lie exactly on the x or on the y, which is what the equations we've had before have dealt with. These axis rotation formulas let us rotate our axis. So into some UV coordinate system where u is this axis and v is perpendicular to it. So u is like the new x and v is like the new y. But in UV space, this ellipse is perfectly horizontal. So if the u-axis makes a first quadrant angle theta, so this distance here, that's the angle theta, then the axis rotation formulas become this. So x equals u cos theta minus v sine theta, and this is the y formula. So consider the conic section with equations x squared, 13x squared minus 6 root 3 xy plus 7y squared equals 16. Use theta equals pi over 3 as the angle of rotation to write in a rotated coordinate system with no UV term. So x is going to equal u times the cosine of this angle. Well, the cosine of root 3 is 1/2. So it's going to be 1/2 u. The sine of that angle is root 3 over 2. So that's my x. Y is u times the sine, so root 3 over 2 u, plus 1/2 v. So there's my equations that I'm going to use. So now what I have to do is I have to take this equation and plug it in. So 13x squared is going to be 13 times 1/2 u. And since it's squared, I'm going to have 2 copies. I'm going to go ahead and just write it out, expanded now. So that's 13x squared minus 6 root 3 x 1/2 u minus root 3 over 2v times y root 3 over 2 u plus 1/2 v plus 7y squared, which is going to be root 3 over 2u plus half v times root 3 over 2u plus half v, and then all that's equal to 16. Now, what happens is a bunch of math. I get to do a bunch of foiling, a bunch of distributing, and all of that other fun stuff, which I really didn't leave myself a whole lot of room for. So let's see how badly I can do this. So 13, so that's going to be 1/4 u squared. It's going to be, let's see here, so that's going to be negative root 3 over 2 root 3 over 4 v minus another root 3 over 4 v. So that'd be doubling that. So minus root 3 over 2 uv plus negative root 3/4 v squared. So that's expanded, minus 6 root 3. This one's going to come out to be root 3 over 4 u squared. That's that one. Then it's going to be, that is 1/4 uv minus 3/4 uv. So 1/4 minus 3/4, 2/4, which is 1/2 uv. And then the last ones would be minus root 3 over 4 v squared. So that's those expanded. All right, plus 7. Let's see here, 3/4 u squared. So that's going to be root 3 over 4 uv plus root 3 over 4 uv. So plus root 3 over 2, because I have to double it, uv. Plus 1/4 v squared, all that's equal to 16. Okay. So what I actually need to do, and I'm not going to show all the steps, is gather up all of my u squareds I would distribute, because I've got u squareds, I've got uv's, and I got v's. So I need everything that's got a u squared. So what would happen is the u squareds, well, there's 13/4 for the u squareds. Over here, I've got, so negative 6 over, so that's going to be 6 times 3 is 18 over 4. So that's minus 18/4 for that one. Over here, plus 21/4. So that's all my u squareds. Then I need my UVs. So there is negative 13 root 2, root 3 over 2. That's that one. Here would be plus 6 root 3 over 2. That one. And this one would be plus 7 root 3 over 2. And then I do my v squareds. So v squareds, here I have minus 39/4. That's that one. Here I'd have plus negative 6 and negative, that's going to be 18/4. And then this one would be plus 7/4. And then all this is still equal to 16. And then I can just do my addition. So 13/4, this all works out to be, actually let's get my calculator. So how many u squares we got? We got 13 minus 18 plus 21. Whoops, 13 plus 18, oops, minus 18 plus 21. So that's 16/4, which is 4. So 4u squared. These cancel out. There's negative 13 plus 6 plus 7, so the UVs are gone. No UV term. Over here I got negative 39 plus 18 plus 7. So that's, I feel like I've done something wrong there. That's positive 39. That's my problem. Where did I lose its sign? V squareds. Oh, it was just 3/4. That's a plus sign. So 39 plus 18 plus 7, 64. So plus 64 v squared equals 16. So since I want this, I have to divide by 16 because I want this to equal 1. So u squared over 4 plus, no, that's not 64. That's 16. V squared over 1 equals 1. So that's a squared. That's b squared. So let's see here. Identify the type of conic. This is an ellipse. Means it's addition. Find its vertices, its foci in the UV system. So the vertices are going to be plus or minus 2, 0. The foci, let's see, a squared is equal to b squared plus c squared. So the foci will be plus or minus root 3, 0. Now the bigger thing's under the u, so it's going to run left, right. Let's see here. The eccentricity is c over a, which is, let's see here, root 3 over 2. Back in the original coordinate system. Okay, so to go backwards, I know my in u and v, so the vertices, that's u, that's v. Here's my formulas, so I would plug 2 and 0 back into these formulas. So if I use positive 2 for the vertex, I get 1 for the x, and I get root 3 for the y. If I plug negative 2 in, I get negative 1 and negative root 3. So I'm plugging u and v into these formulas, but I have to do it twice, one for positive 2, one for negative 2. For the foci, I do the same thing, plug root 3 positive and 0 into these equations to convert them. So that would give me root 3 over 2, comma, 3/2, and negative root 3 over 2, negative 3/2, if you work them out. The eccentricity is actually the same because eccentricity doesn't depend on the orientation. It's a property of the ellipse itself. Okay, so Given this garbagey equation, ax squared plus bxc, so all these terms, a rotation angle theta that will result in a transform equation with no cross products terms like the one we did before is found by doing this. So the cotangent of 2 theta is a minus c over b, where a, b, and c are these first three coefficients here. And assuming your angle is between 0 and pi over 2, because you want to measure in the first quadrant. So use rotation formulas to limit the cross product term with the quadratic equation, blah, 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 blah. All right, so for this problem, a is 1, b is 4, c is also 4. So the cotangent of 2 theta is equal to a minus c over b. So the cotangent of 2 theta is equal to negative 3/4. Let's see here. Oh dear. So let me work out what theta is. So we don't like cotangent, so tangent of 2 theta, if we do the reciprocal, will be negative 4/3. So let's see how badly this goes. What am I in? Sorry, I'm trying to find my mode. Radians, okay. So the inverse tangent of negative 4/3. So that's my angle, divided by 2, gives me that. So the cosine of that value is 0.89. We need to use some definitions. Because now I can use it to draw a triangle. Sorry. So 4/3. I'm sorry, negative 4/3. Opposite over adjacent, which means this is 5. So that angle there, so cosine of 2 theta is equal to negative 3/5, because that has to be the one that's negative. And then I can use half angle formulas to figure out what these things are. So the cosine of theta, this is from a previous section, it's 1 plus the cosine of 2 theta, which is negative 3/5, all over 2, which just comes out to be 1 over root 5. Sine of theta is the square root of 1 minus the double angle, which becomes 2 over root 5. So x, so this is our x and y formulas from before, is cosine u minus sine v, and the other one is sine v plus cosine, sine u plus cosine, forgot all my roots, v. So get all this, then I need to make my substitutions into this formula. Okay, so all this garbage goes back in here like we did before, and I'm going to skip all the math because I don't want to derive it. So it simplifies to 5u squared minus 42 root 5 u minus 6 root 5 v plus 450 equals 0. So if we really want to complete the square, this fun thing ends up being a parabola because you have one square term. All right, we've got here is what's referred to as the discriminant test. So the second degree equation, blah, 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 graphs as a hyperbola. If the discriminant is more than 0, parabola b squared minus 4ac is equal to 0, and ellipse b squared minus 4ac less than 0, except for degenerate cases. So identify the conic sections in example 1 and example 2. Where did example 1 go? So example 1 was this, so A, B, and C. So for example 1, A was 13, B was 6 square root 3, negative, and C was 7. So B squared, so negative 6 root 3 squared minus 4 times A times C. So math, calculator, parentheses, negative 6 root 3 quantity squared minus 4 times 13 times 7 gives me negative 256, which is less than 0, and that thing was an ellipse, which we already did. Ellipse, yay. For 2, let's just one up here, A was 1, B was 4, C was 4. So B squared minus 4AC is 16 minus 16, which is 0. And according to this, this was a parabola, has 1 square term. So that's how you can quickly tell which one is which. All right, example 4, match each quadratic equation with the appropriate graph described below. Okay, so hopefully this isn't too terribly garbagey. All right, let's see here. So that one, we each use everything once. So this looks like it should be an ellipse, but since it's equal to 0, that means there's only one point that works. So this, actually, I think that's, no, there's a typo. That should be a single point. So number 1 is C. 2, once again, we've got a 0 over here where we should have a 1. So this would collapse to 2 intersecting lines. So this would be E. Number 3 would be if we do the discriminant test, it would be a parabola, but it doesn't factor correctly. So the only solution is line y equals negative x. So this would collapse to a single line. Y minus x quantity squared would be a parabola if we did the discriminant test, but is equivalent to x minus y is plus minus 1, which means that we have 2 intersecting lines. I did that one, sorry. 2 parallel lines. And which means the last one has to be A, the empty set. So the reason that that one's an empty set is that when these are squares, so when they sum, the squares are always positive, they cannot add up to a negative number, which means there is no solution that works. So, and that is the end of the section.